In the last episode, I showed you how to install Kubernetes on the Turing Pi cluster running on 7 Raspberry Pi compute modules. In this episode, I'm going to show you some of the things you can do with a Kubernetes cluster. In the last episode, I explained in a very basic way how Kubernetes works. It basically runs applications across all your servers. To help manage Kubernetes, there's a handy little tool called kubectl. Sometimes I call it kubectl, but if we go down that road, I have to start talking about why it's called a GIF and not a GIF, and why spaces are better than tabs, or why vim is better than emacs, and I really don't want to go down that road.
Richard, what's wrong?
Nothing. Literally, it's all good.
I won't go into a deep dive on managing Kubernetes in this series, because that could be its own 24-part series. But I will be using kubectl a lot to deploy apps on the cluster and to check on their status or to make changes to them. There are usually many ways to do the same thing in Kubernetes, and I'll let you decide if that's a feature or a bug. And just as a warning, there may be a few parts of this episode that are a little over your head. And that's okay. That's kind of how it is working with Kubernetes. The only way to learn is to build test clusters, make them fail in new and exciting ways, and then start over again. I like to think of it like every second you're working right at the edge of your understanding. When it works, it's magic, and when it doesn't, well, good luck. No, I'm just kidding. I'll try to help you understand the basics, and once you start building your own cluster, hopefully you can start to understand how it all works together. One of the most frustrating things that you run into if you're trying to do things with Raspberry Pis or any ARM-based single-board computer like the Raspberry Pi is the fact that many applications and container images aren't built for the Pi. So you end up in a cycle like this. You think of some brilliant way you could use the Pi cluster, and you search for how to do brilliant thing X in Kubernetes or K3s. You find a repository or a blog post with the exact thing that you're trying to do, and you deploy the thing to your Pi cluster and it doesn't start. You check the status and Kubernetes is saying it's stuck in a crash loop backoff. So you go check the logs and you see exec user process caused exec format error. This happens more often than I'd like to admit. You see, the problem is most container images, like the ones you see on Docker Hub or Quay, are built for typical x86 computers, like for the Intel or AMD processor you're probably using on your computer right now. Most are not also built for ARM computers like the Raspberry Pi. And even if they are, there are many different flavors of ARM, and maybe it's built for 64-bit ARM, but not for 32-bit ARM that you might be running if you're not on the 64-bit version of Raspberry Pi OS. It can be, well, a little complicated. And sometimes if you really want to do something and can't find a pre-built image that does what you want, you'll have to build your own container images. It's usually not too difficult, but especially when you're quickly testing new ideas out, where other people may have already done the exact same thing and did the work for you, but you can't use it because it's not compatible, it can be a bit frustrating. To illustrate, let's look at one of the simplest Hello World examples from Kubernetes' own documentation, the Hello Minikube example. If I create the Hello Node deployment with kubectl create deployment hello node and then pass it the image, and then I check on its status after it's deployed using kubectl get pods, after a couple minutes, I'll see the pod in crash loop backoff state. And if I check the pod's logs with kubectl logs, I get, you guessed it, exec format error. No! And not to be discouraging, but sometimes when you want to solve a problem with Kubernetes on a cluster of Raspberry Pis, you're kind of inflicting the pain on yourself. Imagine this scenario. You want to run a Minecraft server on your cluster. Now think about all the other people in the world who run Minecraft servers. How many of these people not only run a Minecraft server, but run it in a Docker container, in a Kubernetes cluster, on a Raspberry Pi, which might be running a 32-bit operating system? The amount of people who are doing the same thing that you're trying to do is usually pretty small. So, like early explorers, you may have to do some extra work to get things working. Google is your friend here because often there are one or two other crazy people like me who are doing the exact same thing, and finding their work can help you a lot. Now, for the rest of this video, I'm going to show you what I deployed to my Turing Pi cluster and how I did it. So the first thing that I usually do with a Kubernetes cluster is I want to make sure that I can know what's going on inside the cluster. So I use some monitoring tools to see how the CPU and memory are affected by things that are running on the cluster. And the best thing for that, in my opinion, is Prometheus and Grafana. Prometheus collects metrics from all your servers and all the running applications, and then Grafana can display them in nice fancy dashboards. So there's a project from CoreOS called Prometheus, and this is pretty much the standard that people use when they want to run Prometheus and Grafana and AlertManager on their clusters. And that's what we want to do. So I'm going to go ahead and try to use it. I'm going to use Git and clone the project to the Raspberry Pi, to the master node, and then try to apply it using the quick start guide here. So I'm going to log into the Raspberry Pi, pirate at Turing master, and I'm going to switch to the root user account. You can actually set it up so that you could do it as the pirate user, or you could do it from another computer too, but for consistency's sake, I'm just going to do it in here. Clear that, and now I'm going to clone this project using Git. Actually, I'm going to go to my home directory, which is pwd, which is root. So I'm in the root folder now, and I'm going to clone this project with Git. Git clone, paste that in, and it's going to grab all of this repository data. And then I'm going to go into the README and look for the quick start guide, which is right here. And it says basically that there are some manifests that you can apply to your cluster, and it will set everything up for you. We'll get into what manifests are and how they work in a bit, but I'm just going to try this and see what happens. So we'll create the setup manifests, have to cd into the kube Prometheus directory, and then I'm going to run these two commands. So apply the setup manifests, and then run this command to make sure that everything's working. And that command is not giving me anything promising, so I'm just going to try running this command by itself and see what it gives me. No resources found. So sometimes when this kind of thing happens, you'll need to use kubectl to investigate what's going on in your cluster. So I'm going to see, I know from past experience that this Prometheus project actually sets up a namespace, the monitoring namespace, and I can see that also if I use kubectl get namespaces. It'll show me that there's a new monitoring namespace, and it says that it was created 42 seconds ago when I created all of these things. So you can see it was the first thing it created up here. So I'm going to look and see what pods are running in there. In Kubernetes, pods run containers and applications, and they're kind of the basic unit of Kubernetes application management. There's a lot of different ways to manage those pods in Kubernetes, but I know that pods are the things that actually get the work done. So I'm going to get all the pods in that monitoring namespace using kubectl get pods -n monitoring. And that's going to show me that there's a pod in here that's stuck in crash loop backoff. I think I've seen this before. Let's see what's going on. I'm going to get the logs out of this pod. So kubectl get, or kubectl logs -f -n monitoring. And then I'm going to see, this is going to show me the logs, and it looks like there's actually 2 containers in this pod. And there's 2, so let's see what's going on in the Prometheus operator. Maybe it's crashing. So I'm going to say kubectl logs -f -n monitoring, and then the operator pod and -container, and give it that one. And it looks like Prometheus is actually working okay. I don't see any problems here. Let's check this other container and see what's going on. So I'm going to Control C to get out of that. And I'm going to look at this container. There's our old friend, the exec format error. So apparently this kube RBAC proxy thing is not going to run on the Raspberry Pi. And I'll cut this story short and not make you sit through this whole process. But I actually found this problem when I was working on this and trying to get it to work. And so I opened up an issue on GitHub about this. Basically, the kube RBAC proxy pod, which runs alongside the operator pod, or container, I should say, it is not compatible with the ARM v7 Raspberry Pi 32-bit operating system that we're using. So it gives us this error, and we're going to have to find out a different way. Now, I'm going to cut a bit of time out of here. Actually, the first time I tried doing all this, I found this problem, and I started investigating whether I could port this project to something Raspberry Pi compatible on my own, and I got pretty far. I got almost everything working. There were a couple little things that weren't plugging in together. But then in the midst of all that, I found another project by somebody named Carlos EDP, created this cluster monitoring project, which is, it's basically the same thing as Prometheus, but a cool thing that he did is he made this all work really well with Raspberry Pi and ARM-based clusters. So any kind of ARM single board computer, it runs really well with this cluster monitoring project. It even gives you things like CPU temperature monitoring, which is really cool because you can see if your Raspberry Pis are going to be throttling when it's running Kubernetes workloads. So what I'm going to do is I'm going to delete all the things that I just created because I don't want to run the Prometheus project. It's not worth the time to try to get that working. Sometimes when you run things on the Raspberry Pi, you just kind of need to find a better, faster way, and this is the better, faster way because somebody already did all this work for me. So I'm going to say kubectl delete -f, and then it was in manifests/setup. So that's going to delete all the resources that I had just created. And I'm going to go back a directory, and I'm going to remove the Prometheus project because I'm not going to use it. So now I'm going to grab this project, which I know is built for the Raspberry Pi, so it should work a little bit better. So I'm going to say git clone that. Then I'm going to cd into the cluster monitoring directory, and I'm going to follow this quick start guide. So let's see what it tells me to do. A cool thing about it is that it has directions for a Kubernetes cluster, Minikube cluster running on your local computer, or even K3s. So it's tuned for all these different scenarios. So I'm going to need to edit this vars.jsonnet file and change a few settings for my cluster. So I'm going to say, I'm going to look and make sure it's in here. So there it is. I'm going to use nano to edit that file. And I'm going to find the K3s enabled setting. So I'll go down to find that. Here it is, K3s enabled. I want to set that to true. And then I also need to change the master IP. So I know that the master IP on this cluster is 10.0.100.164. And I'm also going to change the suffix domain here to have one of the IP addresses of one of the worker nodes that's going to be used when I access services running on the cluster. So I'm going to choose 10.0.100.99. I think that's worker 02. So I change that, and then there's also a setting. It's not mentioned right here, but you can set it up towards the top that turns on the ARM exporter that gives you data about CPU temperature, things like that. So I'm going to say true for that. Those are all the changes that I'm going to do for now. There's other things you can change in here, and you can read the documentation for that for your own cluster. But that's all I'm going to do for this particular setup. And I'm going to hit Control-O to write the file, and then Control-X to exit. And now I'm going to run a couple commands to build the manifest for my particular cluster. Now there's a couple things that you need to install if you don't have them already installed. I do on this Raspberry Pi, but you need to run apt-get update to update your apt caches, and then run apt-get install -y build essential, and that's going to install the make utility along with some related things, and Golang to make sure that you have the Go language installed on your Raspberry Pi. And I already have them installed, so it should say that, and then go back to the command line. So now that we have those dependencies, I can run make vendor. And so I'm going to take that, clear this, and I'm going to run make vendor. This is going to take a little while. And then I'm going to run make. And this will also take a while as it generates all of the different YAML manifest files. All right, so it's generated all of the YAML manifest files that Kubernetes needs. So now I'm going to do the same kind of thing I did with the Prometheus project. I'm going to apply the setup manifests. And that should create a monitoring namespace and all of the different things that go inside of it. And then I'm going to apply all of the other manifests that are generated. And now that those have all been created, Kubernetes is going to start taking all the things that were just created through all these manifests and start scheduling them on nodes. So you can watch that process if you use kubectl get pods in the namespace monitoring. It will show you what's going on in there. And you can see that a lot of these pods are already running, one of them still creating. If you want to watch it, you can use the watch command, and it will let you see that updated every couple seconds. So you can see that Prometheus is still getting up and running, the container's creating, it's likely pulling down the information to that Raspberry Pi, the Docker image that's going to run Prometheus. But you might notice that there's a lot of instances of some of these things. There's a bunch of ARM exporters, there's a bunch of node exporters. That's because this project sets up a bunch of different pods, one on every single Raspberry Pi, to do things like get all the CPU metrics, get all the memory metrics, and get the temperature data and send it all into a central Prometheus instance. And we'll see that very soon once Prometheus starts running. Sometimes when it's starting up, you might see an error the first time it starts, but it usually gets into the running state pretty quickly. And at this point, I can also see if there is a way to get to these by saying kubectl get ingress-n monitoring. And ingress is just a way for Kubernetes to give you a nice host name to access your services that are running. And we'll talk a little bit more about some of these things in the next deployment that we do. So Prometheus is running here, and Prometheus is aggregating all of the monitoring data coming from throughout the cluster into it. And Prometheus lets you browse all that data, and there's a lot of it. There's hundreds and hundreds of different things that you can monitor. And most applications that run in Kubernetes also put out metrics endpoints that can be aggregated in Prometheus. And it gives you things like, let's just do a really simple one, up. And you can see that these are all 1. That means that they are up and running. So you can monitor whether things are up or down. You can graph it. And obviously, since everything is up and running, there's a lot of different things that are just 1 here. But Prometheus monitors all these things. It's not the best interface for something like a dashboard to see how things are doing at a glance. But Prometheus is important to get all that data together so that you can browse it and see what's going on in your cluster. And if you go to this target section, you can see that everything is up and running and sending data to Prometheus. So Prometheus is happy and getting all that data together. Now, to be able to browse that data more conveniently and in a little bit more usable way, Grafana is a great system for monitoring dashboards and alerting and sending you emails when bad things happen. And we can access it on this host name. And the default login is admin, and I don't want to save that password. And it'll prompt you for a new password when you log in the first time. So I'm going to set a new password. And then it takes you to its dashboard. Its dashboard can be customized. You can put different things on here that you want. You can star different dashboards on it. But I'm going to go to the dashboard browser under Manage and click on Default to show all the dashboards that come with this cluster monitoring project. And thank you again so much to Carlos EDP, Carlos Eduardo, who has set this up. It basically saved a lot of my time in trying to do this stuff myself. And he set up a custom dashboard that's tailor-made for K3s clusters on Raspberry Pi called Kubernetes Cluster Monitoring via Prometheus. If I go here, it gives us a lot of great information. It tells us memory usage on the whole cluster, CPU usage on the whole cluster, tells me if all the nodes are up or if any of them are down and how long they've been running. It gives me graphs of that data so I can see over time how things are running. It can even monitor the Pi's CPU temperature. So you can see a few of these Pis, like the master is 60 degrees Celsius because it's doing a lot of work coordinating all these other pods and scheduling things on different Raspberry Pis and managing our whole cluster for us. And some of the other Pis, like down here, worker 06 is only 47 degrees Celsius because I guess it's not got much going on. There's also different alerts set up so that if something goes bad, like if the CPU usage goes too high, it'll start alerting on that, or if the temperature gets too hot and the Pi starts throttling. And there's other graphs down here too. But the great thing is now I can monitor my cluster and make sure that when I'm deploying different applications on it, or as I'm running applications, I can make sure that I'm not running out of memory or running out of CPU, or I don't have nodes that keep going up and down, which can happen sometimes, especially when you're running with Raspberry Pis with only 1 gigabyte of memory on them. So now that I have a monitoring system in place, I can start to deploy other things on the cluster. Now that we have a way to monitor our cluster and see how things are running on it, it's a good idea to start running some things on the cluster. So I'm going to set this dashboard to update just the last 15 minutes, just so I can see what's going on. The cluster's been pretty stable. Everything's running well. I don't see any spikes in usage or anything because the only thing that's running is the monitoring. But I'm going to run some software on it that I'm very familiar with because I'm an open source developer who started off using this software years ago when I set up my first website, and that is Drupal. I'm going to install Drupal on this cluster and see how it works. I have a very basic installation of Drupal, and the way that I'm going to install it is just using some Kubernetes manifests that I'm going to create using YAML. And I have these up on my GitHub gist site under Drupal.yaml. A manifest in Kubernetes is basically a way of describing something that you want to run on the cluster. And there's a lot of different things you can put in a manifest. In this manifest, there's a config map, which is kind of like a settings file or some data that you want to put into a container that runs in Kubernetes. So this is just a configuration for Drupal. And a note here, this is not the most secure way to do this. There's better ways to do this, but for the purposes of demonstrating this in an episode today, I'm just doing it this way. So there's a config map that has a configuration. There's a persistent volume claim. This tells Kubernetes, I want to have some space to write files and have that be persistent. So even if Drupal dies or the node fails, I want to make sure that those files still exist so that when a new container is created, those files don't just disappear. So I'm going to create that. And then there's a deployment, and we saw some of these deployments from the monitoring system. A deployment basically says, I want to have a container running. I want to have a pod in Kubernetes that runs, and if it fails, I want it to restart itself, and I want to be able to scale it up, so have multiple instances of that container running, and I want to be able to deploy updates to it in a rolling fashion so that it deploys a new one, the new one is online, and then it takes down the old one. So Kubernetes will manage all that for us if we just use a deployment. And you'll notice that I just have replicas 1 here, and that's because this really simple example might or might not work that well if I have multiple replicas. With most applications, you'll need to make some modifications and set them up a little bit more custom to make sure that they work correctly if you scale them up beyond one instance. But this will work for our demonstration purposes. And a deployment, a lot of this stuff, this is Kubernetes YAML, and there are plenty of memes around about Kubernetes YAML usage. And initially, when you start using it, you're going to be kind of drowning in it, and it can feel a little overwhelming. But after you start working with different Kubernetes resources, you kind of understand how it works. And it's kind of like the Matrix. You don't see the YAML anymore, but you see the resources. You see a config map and a persistent volume claim. And you see a deployment, and you see the things in the deployment that come from the other resources. And then you see services that expose the deployment to the world. And then you see ingress that lets people access your application. So it's a little bit overwhelming in this video. I don't have time to explain all of the different types and all the different options and parameters. But at a very basic level, when you get a request for Drupal on this cluster, once we get this running, we'll request this host name, and then this ingress resource will tell Kubernetes, hey, when I get a request at this host name, I want to send it to this Drupal service on port 80. And then this Drupal service, which is running on port 80, is going to say, hey, I'm going to go to the Drupal app. And the Drupal app is running up here. And it's going to say, hey, I want to run this request through a container that's running Drupal 8.8 on Apache on port 80. And then Drupal will say, okay, I'll serve that response. And for that, Drupal also needs a database. So there's another manifest for MariaDB, which is an open source database that you can use with Drupal and WordPress and other things. And it's going to have the same kind of setup. It needs a persistent volume so that the data in the database can stay on the cluster even if the database container goes away or needs to be rescheduled on another node. And then there's a deployment that tells it, hey, I want to make sure this database is running all the time. And there's one replica. Databases can be a little bit complicated to run in Kubernetes, but most of the time they're not so bad if you just need to have one replica and don't need a cluster of database setups. And then the database has a service. This service is not exposed to the outside world. It's only going to be accessible by Drupal in the Drupal namespace. And that's one thing that's really nice about Kubernetes is you can say, I want a namespace for all my Drupal stuff, and I want another namespace for my monitoring stuff, and I don't want the monitoring things and the Drupal things to interact with each other because the monitoring system doesn't need to see the database that Drupal sees. There's other things that you can do for security too, but namespaces are a very helpful way to organize resources by application in a Kubernetes cluster. So what I'm going to do is take these two manifests. I'm going to take the Drupal one and copy it. I'm going to cd back into my home directory, clear this, and I'm going to make a directory for Drupal, cd into that directory that I created, and I'm going to create a file called drupal.yaml with nano. Paste that manifest, save it with Control-O, Control-X, and then I'm also going to make a MariaDB manifest. So copy that, nano MariaDB.yaml, paste it, save it, and now I have these two manifests that I'm going to deploy into my Kubernetes cluster, and I'm just going to use kubectl apply-f and give it the manifest file drupal.yaml. It's going to create all those resources. You can actually apply multiple manifest files in one instance. And in this case, actually, I forgot to do what it says up here in the documentation. I have to create a namespace for this to run in. So I'm going to create that namespace first. And then I'm going to apply this manifest. And then I'm going to apply the MariaDB, db.yaml. And now it's going to create all these things. So if I say kubectl get pods in the Drupal namespace, it should show me that these containers are creating. And let's watch that and see, let's watch that and see how long it takes. What it's doing is it's downloading the Drupal Docker image, whatever the image is in this manifest, to the Raspberry Pi where it's running. And it's also going to download the MariaDB image to the node where it's running. And we can also check, if I go out of here, I can say kubectl get pods -n Drupal for the Drupal namespace, and then -o wide. And that gives a wider output that has more information. And you can see that it's scheduled Drupal to worker 03, and it's scheduled MariaDB to worker 04. A cool thing that Kubernetes is doing for us, and I'm going to go ahead and go back here and see when they're ready, is Kubernetes can schedule pods wherever they can fit. So if you have a node that has more memory and you need to have more memory for your application, it will move that application to the node that has the memory that you need. Or if you have certain features, like if you're building a bigger cluster with more things than just Raspberry Pis, you can put a computer with a video card in it, and you can do machine learning processing on that computer and tell Kubernetes, hey, this application needs to run on the computer with the dedicated video card. So there's a lot of different things you can do with Kubernetes scheduling by configuring your applications the right way. And you can see here that Drupal is running, but it's not yet ready. That's because in Drupal, in this deployment, we have these probes that Kubernetes uses to know when it's ready to actually serve up requests. So until that time, if I say kubectl get ingress -n Drupal, this is going to tell me how I can access Drupal through this URL. And I can load that here until this says ready, which now it says ready. Kubernetes won't route requests to that actual service that's running in the backend. But now Drupal's installer's coming up, so I'm going to go ahead and install Drupal. This is going to take a little time, and it will also give me a warning when I start the installation, because this is a 32-bit operating system and can't store dates that are beyond the year 2038 because of limitations of 32-bit PHP. But I'm going to ignore that error and go ahead and install Drupal. While Drupal is installing, you can even go to the Grafana dashboard, and you can see that some of the pods' CPU and memory is going up a little bit because Drupal's installer takes a bit of power and a bit of memory to be able to run. So Drupal is running on worker 03, and you can see that its memory consumption is a little higher, as well as its CPU. And we can also check on the Raspberry Pi temperature, and the temperature's gone up a little bit, but we're still well under the throttling threshold, so we're safe for now. And now that Drupal's installed, I'll configure the site for the Turing Pi. And there it is, we have Drupal running on the Turing Pi cluster. Drupal is a pretty good CMS, and a lot of people do like it, but there is a CMS that's a little bit more familiar to more people and has been around about the same amount of time, and it's also built in PHP, and that's called WordPress. So I'm going to go to another configuration that I have for Kubernetes for WordPress. And if you look at it, a lot of the things in this configuration are going to be almost identical to Drupal. It needs a persistent volume claim just like Drupal. It has a deployment that runs WordPress and mounts that volume claim. It has a service that exposes WordPress, and it has ingress that lets you access WordPress. So let's set that up as well. I'm going to go out of here, cd back up a level, clear this, and I'm going to make a new directory for WordPress. Make dir WordPress. And I'm going to go ahead and grab these two manifests. And I'm going to make a new directory called WordPress, cd into WordPress, and then make this file mariadb.yaml. Paste the manifest, save it, close it. Then I'm going to get the other manifest for WordPress, nano WordPress.yaml, paste it, save it, close it, and then I'll say kubectl apply. Actually, this time I'll do it in the right order. I will create the namespace and then I'll apply the resources inside of that namespace. So I'll do that, and then kubectl apply -f WordPress, and then I'll do the same thing for MariaDB, and then I'll watch as it deploys them. Watch kubectl get pods-n WordPress. So it looks like it's creating those containers. I'm going to go ahead and get the ingress and see see if I can show you what happens if you try loading this before it's ready. So Kubernetes is now not routing traffic to this WordPress backend until the point that it is saying that it's ready. So you can see it's still not ready, and so we're getting service unavailable. All right, so it says that everything is running. I'm going to go back over to the browser and refresh this page. And it should be giving me the WordPress installer at this point, which it is. And so I'll fill this out. And I'll give it a weak password. Test@example.com. And I don't want search engines to index the site, even though it's running locally in my house and will not be accessible over the internet at all. And now I'm ready to log into it. All right, so I have a WordPress site running here, and if I go here, this is the new WordPress site that I have. So now I have Drupal and WordPress both running inside this cluster, and if I look at all the pods, so I'm going to say kubectl get pods, and then give it all namespaces, and then say -o wide. I'm going to see where these pods are running. Kubernetes has distributed the pods across all the different nodes. So you'll see that there are pods running. Let's see, where's Drupal is running on worker 03. Drupal's MariaDB is on 04. WordPress is on 02, and its database is on 05. So Kubernetes is spreading these resources over all the different Raspberry Pis to make sure that all the different applications I have running have all the resources that they need to be able to run well. And that way, if I were to do a load test and load this WordPress site and load the Drupal site over and over again, those requests would be getting routed to the different nodes, and the resources would be shared, and it's a lot easier than trying to deploy things yourself, especially if one of the nodes goes offline, because in that case, Kubernetes can see, oh, worker 05 is down, and after about 5 minutes or so, it'll start rearranging things and putting things onto nodes that are running. So WordPress and Drupal are nice. There's some good applications for running websites and things, but usually when you're using Raspberry Pis, you want to have a little bit of fun. So in my case, sometimes I like to have fun by playing Minecraft. Minecraft is a game that's been around since 2014 or 2015. I don't remember exactly when. I think I started playing it around 2015. But Minecraft lets you play, and it's kind of like, I like to think of it as Legos, but in a computer. And there's lots of different things you can do with it. And Minecraft has a server that you can run so that you can play a private game or a public game with other people that is running on a single server, so you can have multiple people join in the same game. And you can run this on Kubernetes, and if you search around for Minecraft Kubernetes, like you might do if you wanted to run it on Kubernetes, you might find that there's a Helm chart for it. So I'll look for Helm in here. And Helm is a popular thing for running applications on Kubernetes. And there's a lot of different ways that you can run things on Kubernetes. Helm is probably one of the most popular. A lot of people also just use plain manifest files like we did for Drupal and WordPress, and you might use other tools like Customize, or you might use something like Ansible and template those files. But Helm is yet another way to deploy them and to have values that are templated in place in these things. And there's lots and lots of different Helm charts. It just so happens that this Minecraft one works pretty well for our needs because it can be made to run on Raspberry Pis, just like any other Kubernetes cluster. So to get these running, you actually need to install Helm first, and I believe I already have it installed. You can check by running Helm and see if it outputs Helm's help. But I'm going to clear that away. If you need to install Helm, it's pretty simple. You can just search for install Helm, and it will give you this docs page that says download the right version, and then expand that version, and then copy the Helm binary out of it into user local bin. So if you're using a Raspberry Pi, like in this case using Hypriot OS, which is 32 bits, you would download this Linux ARM version. If you're using Raspberry Pi OS 64-bit or another 64-bit OS, you would use Linux ARM 64. So I downloaded that and I copied it into the user local bin folder, following these directions. And now I should be able to start installing Helm charts, including this Minecraft chart. However, I'm going to need to customize it a little bit for the Raspberry Pi. So if you look at this, it has a command down here. First, you need to make sure that you have the stable repository that this is in. So if you go to Helm charts, you can see in the README, in the documentation, it says you need to run this command to enable the stable repo. So I'm going to go ahead and do that now. That adds the stable repository that has the Minecraft chart and tons of other charts that are in the same repository. And then after that, it wants you to deploy Minecraft into your server. But one thing that I want to do is make sure it's in its own namespace. So this default command doesn't have a namespace, so I'm going to use a namespace. I also need to specify some things. I need to accept the end user license agreement, which this is doing. But I also need to specify some other things, like I need to make the world size a little smaller to be able to run it well on a slower Raspberry Pi compute module. And I also need to make the view distance a little shorter too. That's another thing that you can do in Minecraft to make it a little speedier. So I'm going to do those things with some values that I can specify in a values file. And I have that values file. I have those set up already because I set this up before this video. And I'm going to create a values file. I'll call it minecraft.yaml. And I'm going to put these values in it. So there's a few other things too that I do that I customized it. I set these probes that say whether it's running or not to have a little bit more of a delay because it takes a while for Minecraft to generate the world that it is going to run on the server the first time it runs. And on the Raspberry Pi compute module, it can take up to 15 minutes. On your laptop, it would maybe take a minute or less. And on a new Raspberry Pi 4, it only takes a couple minutes or up to 5 minutes. But since it takes a bit longer, I had to customize this. I also set the version of the Minecraft server to run. I told it to agree to the license agreement. I put it on easy difficulty so I didn't get exploded by whatever those little guys are that run around and explode you. And I also put a message, the message of the day, that pops up when you join the server. And I reduced the world size and view distance a little bit. So I'm going to save this file. And now I'm going to run the command to install this chart. First, I need to create the namespace for it. So I'm going to say kubectl create namespace Minecraft. And then I'm going to run this helm install command, which is going to install this version of the chart 122 in the Minecraft namespace that I just created, using all the values in the file that I just created. And it's going to call this helm deployment Minecraft. And it's going to get it from the stable/Minecraft. So the stable chart that we installed up here and the Minecraft chart that's in it. So I'm going to go ahead and run that, and it'll take a little time. If you get an error about it not being able to connect, you might need to make sure that the kube config environment variable is set correctly so that Helm knows how to connect to the K3s cluster. And apparently I have the wrong name for this, so let me choose minecraft.yml instead of YAML. That's the one thing that sometimes I use .yml, sometimes YAML. I don't know why I do that. I should just use one or the other. but you'll find that a lot of times in the Kubernetes ecosystem. A lot of things use YAML, a lot use YML. So now everything is running, and I can get this service using this command, get the Minecraft service. So I'm going to go ahead and run that. And this is going to give me the IP address over which I can access Minecraft from any other computer on my network. So it's this IP address and this port number, 3767. So if I open up Minecraft, it's been a while since I've opened this on my computer. Hopefully it doesn't kill the computer by doing updates or something like that. I'm going to open it up and try to connect to this local server. And it's probably going to fail the first time because Minecraft, like I said, takes quite a while to actually start loading. So I'm going to say kubectl git pods -n Minecraft. And it says that it's running, but it's not yet ready. That's because it's generating the world probably right now. So while it's doing that, I'm going to go ahead and say kubectl logs -n Minecraft, and then give it this pod. And this is going to tell me what it's doing right now. So it's doing some stuff still. It's not yet set up. I'm going to use -f, and that way it's going to follow the logs on that container and see what it's doing. So you can see it's loading recipes, it's loading advancements, all these other things. Meanwhile, it looks like Minecraft itself is running right here. And if I try connecting to the server at this time, I'm going to try using direct connect using the IP address up here. Where is it? There it is. This IP address, .91 port 3767, and it's going to fail because right now it's not actually responding. It's still doing some of the setup stuff. So I'm going to let this sit. I'm going to go back. I'm going to let this sit, and we'll see how long it takes. All right, so that was excruciatingly long. I know that it was sped up in the video that you just saw, but in real life that actually took a really long time to spawn the area. And that's one thing that I will get into in the next video, and I'll mention that in a bit, is the benchmarking and performance between the Compute Module 3 Plus and the Raspberry Pi 4 and other systems like my Core i9 MacBook Pro that I'm recording all of this on. But anyway, so Minecraft is now running, and it should be working. You can see that sometimes it gets a few ticks behind. In Minecraft, that just means that the server is a little bit overloaded. And as long as that doesn't keep going and keep increasing to hundreds and hundreds of ticks, it's just going to cause no noticeable problems in Minecraft itself. But now the server is running. So I'm going to go in here and get that service again and check what the IP address is. And I'll go to Minecraft itself, which is right here. And I'm going to connect to this server 10.0.100.91 on port 3767. And that should connect us to this Minecraft server that's running. We'll see if that's the case. There's Minecraft multiplayer, direct connect, and it's server 10.0.100.91, port 3767. Let's join, and this should work. We'll see if it actually does. And here we are. We are in Minecraft. You'll notice it's a little bit slow. Minecraft on a Raspberry Pi is not necessarily the fastest thing in the world, but if there's one thing I remember from Minecraft before, it was something like you're supposed to dig straight down. So Minecraft is really fun, and it may or may not be the best idea to run Minecraft on a Compute Module 3 Plus, but it does run, and it can be fun still. I wouldn't run it with lots and lots of users connecting to it or anything on that Pi, but on a Raspberry Pi 4 it might not be so bad. Or, of course, running a Minecraft server on another Kubernetes or K3s cluster is going to be a better option, especially if you want to play online with your friends. Now, there's one other tool that I like to install on a Raspberry Pi on my home network to help me to block ads and to also set up custom DNS rules, and that's Pi-hole. Pi-hole is a really well-supported application. It doesn't have to run on a Raspberry Pi, but it was originally conceived for running on Raspberry Pis because it doesn't use too many resources, and it's a really helpful utility to help you save bandwidth costs and to make things load faster because advertisements and tracking things aren't loaded on pages, things like that. So there's actually a chart, another Helm chart for Pi-hole, and that's let's see, it's Mojo 2600 has this Kubernetes chart that uses Helm to install Pi-hole. And there's a couple settings in the chart values that have to be overridden to get it to run on a K3s running on Raspberry Pis like we have here. So I'm going to do the same kind of thing that I did for Minecraft. I already have Helm running, but this is actually using a different repo. So I'm going to use Helm repo add to add this other repo. And then I'm going to run Helm repo update, which makes sure it pulls in all the latest information from that repository. And then this, of course, is installing this into the default namespace, and I don't want to do that. I also want to supply my own values. So I'm going to grab the values that I have for this to run it on my network with the K3s. So I'm going to say nano, and I'll call this pi-hole.yaml. And these values are going to set a few different options that make it work a little bit better on the Turing Pi cluster. And again, there are some settings in here, like I'm setting the admin password to admin. That's not a very secure default, and if you're using this in the real world, you should probably set that to something else and make sure that you have things set up in as secure a manner as possible. But I'm going to set this, and I'm going to set these options for the load balancer IP to the load balancer server, which I'm using is 10.0.100.99. So I'm going to set those up and then deploy this chart. Save this and exit. And then I'm going to create a namespace for Pi-hole because I don't want this to just go in the default namespace. And once that's created, I can deploy the chart into that namespace. And I'm going to use version 176, which is the latest version of this chart, in the namespace Pi-hole using the values from this file. I'm going to call it Pi-hole, and it's coming from this chart repository, and the chart's name is Pi-hole. So the same thing here, I'm going to say kubectl get pods in the Pi-hole namespace. And let's see if it starts running. So it's pending, so it's going to be running these soon. So let's go ahead and watch this and see how long it takes. All right, so now Pi-hole is running, and I've actually added to my etc host file. So I said nano, and on my Mac I'm doing this. I said nano/etc/host, and then I added into that file a line that says 10.0.100.99 and then pi.hole. So that lets my Mac know that if I try to access this URL, it should go to that Raspberry Pi where this is running. And so if I go pi.hole, I believe I should see the admin console come up here. You can see that it shows the Raspberry Pi statistics. So it's funny, Pi-hole shows the temperature of the Raspberry Pi, and if I go over here, I can correlate that by the fact that this, I believe, worker 01 was the one that was setting up Pi-hole. If I go down to the temperature, I can see that worker 01 is currently at 60.15 Celsius, which is pretty close to 59.6. So Pi-hole is monitoring it, and Grafana is monitoring it through Prometheus. And we can see that Pi-hole is running here. And I can also log in as admin using, of course, the password admin, which is an insecure default, so make sure you change that. And I can see all the activity going on. Now to use this, I can access the load balancer that K3s set up on all the different Pis. So if I say kubectl get service -n Pi-hole, I can see that there's a load balancer set up for TCP and UDP. The TCP one's not actually running right now because it interferes with other things that are running on the servers, ports 80 and 443. So that's going to get stuck in pending state, but the UDP load balancer is running on 10.0.100.99. And what I can do is on my Mac, I can start using my Mac, go through the DNS on this Pi-hole server that's running in Kubernetes. And to do that, I just go to System Preferences, and then Network, and then for whatever interface that you're using, I have an Ethernet connection and a Wi-Fi connection. I can say Advanced, and then change the DNS server. So right now it's just using my router, the default, but I'm going to add this one, which is 10.0.100.99, and say OK, and apply. And now my Mac is going to start using DNS through here, and you can see it already is getting queries. So my Mac is sending web requests now through the Pi hole, and the Pi hole will start blocking things that it identifies as advertisements. So if I go in my web browser to, let's say, cnn.com, then it's going to start loading the page, and there might be some things that Pi-hole starts blocking. And you can see it's blocking 24 queries, and you can go in and look at the log and see what things it's blocking. But a lot of news websites, if you don't use it with Pi-hole, and you notice that they're slow, and then you do use it with Pi-hole, sometimes websites that take 20 or 30 seconds to load might take 1 or 2 seconds because all the advertisements and tracking stuff that happens. So Pi-hole is really awesome for blocking advertising and tracking content that makes the web slower and makes lots and lots of annoying and pop-up and all the crazy kind of ads that happen show up on your computer. So that is Pi-hole, and it's pretty awesome. It also lets you do things like set up local DNS records, so you can refer to your Raspberry Pis by a DNS name instead of by an IP address, and all of those kind of nice things. You can find out more about Pi-hole at pi-hole.net. But that's one of many different things that you can run on a cluster, a Kubernetes cluster like this one. We have monitoring set up that lets us see all of the different nodes that are running and see their CPU and memory usage. You can inspect individual pod usage, all those kind of things. So we have monitoring set up with Prometheus, Grafana, and AlertManager. We have a Drupal website running. We have a WordPress website running. We have Minecraft running so that we can connect to it from our Minecraft game and have a shared server. We have Pi-hole, and there's still capacity left on this cluster, so we could install more and more things until we fill it up. And if we do fill it up, we could add more Raspberry Pis. The Turing Pi board itself only has 7 slots, but you could actually add other Raspberry Pis to the cluster. All you have to do is use K3s to get a token from the master and then join a new node to it. You can add more Raspberry Pis however you want to using K3s or doing it by hand. There's just a lot that you can do with Kubernetes and running lots of different applications on it. And the cool thing about this is all of these applications are scheduled by Kubernetes on nodes that have space, so you don't have to spend time thinking about where you want to run Drupal and where you want to run WordPress and where you want to run Minecraft. Kubernetes takes care of all that for you. And if I were to unplug one of these Raspberry Pis, which is inadvisable because it could corrupt the memory on it, if I were to do that, Kubernetes would, after a certain timeout period, start taking all the things that were running on that and start moving them to other nodes as much as it can, until, of course, it runs out of memory or CPU. So those were just a few of the things that you can run on a cluster. But throughout my time working on these different things, I learned a lot about the limitations of the Compute Module 3+. So I'm really looking forward to the Compute Module 4, which is coming out later this year. It should be a lot faster, and hopefully it will have more options available with more RAM. And it would be really crazy for me to do all this work for these videos and not share it with you. Time and again, you've been very generous in supporting me, like on Patreon and GitHub sponsors. And if you don't already support my work there, please consider doing so. So to give back, I've been secretly maintaining a repository for this project. It's still kind of a work in progress, but it will quickly and automatically bootstrap all the apps that I just showed in this video on your own cluster using Ansible. It doesn't even have to be a Turing Pi cluster, and it doesn't even need to use Raspberry Pis. You can run it on any kind of ARM cluster. And today I'm releasing that project as open source code on GitHub, so you can use it as you like. The link is in the description below. In fact, I ran this automation on my own PyDramble cluster that has 4 Raspberry Pi 4s with 2 GB of RAM each, and then I did a bunch of benchmarks on the 2 clusters to see how they perform. And the results were surprising. In many cases, the PyDramble cluster ran things twice as fast as the Turing Pi cluster. There are a number of reasons for this, but the main one is that the Pi 4 is overall a much better and faster computer than the Compute Module 3+. But how much better, and does the new 64-bit Raspberry Pi OS change anything? And what are my thoughts on the Turing Pi overall after having done all these videos? Well, to find out, subscribe to the channel. In the next video, I'm going to give a more thorough review of the Turing Pi itself. And please comment below if you have any questions about the Turing Pi, K3s, or anything about clustering. I will do a follow-up video soon with questions and answers. Until next time, I'm Jeff Geerling.